Hey, hi everyone. Good morning. Actually, I'm still facing the same issue which I was facing yesterday that I am unable to unmute myself when I'm sharing my screen. Can one of you try sharing this document and see if I've given the permission for you to share the screen? Can one of you try if it's working for you? So if you open the doc and try to share your screen, see if that works for you. Hello, am I audible?
Yeah, we can hear you.
Yes,
Prakash.
Yeah. Can any one of you try actually sharing this document and see if you can unmute yourself?
Yeah, I can try. Yes, I can.
Can you try speaking as well, Manoj, now?
Yeah, yeah. Can you hear me?
I can hear you.
Oh, okay. So then it must be just you.
So you can share and what's wrong with my Zoom. Is it, do you have a Zoom application or you're using
I'm
Zoom
using
web
app.
only?
I'm using Zoom app. Yes.
Is there anyone who is using web, Zoom web?
You can switch to web, maybe and then try.
Yeah, can you give it a try? Or
Yeah.
someone else is using the web? Let's check now. If
I am
anyone of
using, but I am on mobile. Let me connect to my laptop then.
Manoj, you can stop sharing from the other one. Like you can close on it on your application. Try now. And can you speak as well?
Okay. Can you hear me now?
Yeah, we can hear you. Okay. So it's working for you.
Yeah, and the browser also it's working.
Wow, that's very strange. Let me try to rejoin. I don't know what is wrong with my.
Try on different browser probably.
Tried that. Okay, let me try.
Yeah.
Okay. Cool. I think we are good to start. So let's start it today. This is the document which will be using for the discussion purpose. And as I told you today, we'll be starting with the design system design. Design patterns. So design patterns are just some standard patterns which can be used in your design when you're designing the classes, so that you don't end up. And there are some standard principles which has to be followed when you're actually designing these or designing any applications or system. And we'll actually try to understand those principles through some of the design patterns today. Okay. So mainly there are three types of design patterns. One is your creational design pattern. I'll just paste some theory here for your reference so that you can go.
Yeah, Prakar, sorry to interrupt. You're breaking off.
Just give me a second.
Yes, for me also, your voice is breaking in between.
Is it better now by any chance?
Yeah, it's better now.
Okay, cool. And you can see my screen as well, right?
Yes.
Okay. So just a sec. Okay. So basically, as I told you, we'll be discussing about the design patterns today. So there are mainly three types of design pattern. The first one is there are three categories of design pattern. The first one is the creational design patterns. These patterns are designed for class instantiation. They can either they can be either class creation patterns or object creational pattern. Let me try to explain this in a bit more detail. And I've seen that these are the most important ones, generally the builder ones, singleton, abstract factory, and the factory method. These are the most famous ones and highly likely to be asked in your interview as well. What does this means is that basically whenever you have to create an object of a class, or whenever you have to instantiate an object of a class, in those cases you use a creational design patterns. And we'll see more examples of creational design patterns so that it becomes much more clear to you. Then we have structural design patterns. Let me paste this first. So these patterns are designed with regard to class structure and composition. The main goal of these patterns is to increase the functionalities of the classes involved without changing much of its composition. So basically, I'm not sure, but you might have heard of a rule that class should be always uh, open for extension and closed for modification. So structural patterns are generally based on this principle. So basically, your class should be open to have more functionalities. You should be able to add more functionalities into your classes. You should be able to make it more rich in some or the other way. We'll see with the help of these patterns. But you should not change whatever is present in the current class. The composition should not change for the class, but you should be able to add more functionalities to the classes in some of the other way. And we'll see how do we add those with the help of these design patterns. And the third one is a behavioral pattern. These are the simple ones. So basically, these patterns are designed depending on how one class communicates with other. For example, bridge pattern, adapter pattern, decorator pattern, facade, flyweight, proxy. Actually, no one will ask you this. Just I think the most important one here is the decorator pattern, which we'll talk about. Here, some of the important ones are strategy and observer pattern and state pattern. Generally, these are asked, and factory method, abstract factory, singleton, and builder. So we'll try to cover these design patterns as a part of our session. Okay. Now we'll try to start with the first design principle, which we are aware of, and which is very which is extensively used in our design patterns, or sorry, system design. So the design principle one is identify the aspects of your application that vary and separate them for what stays the same. So I'm working on the same, right? Like basically you should not modify your class a lot, and you should be able to separate the ones which will actually, which will vary a lot, and you should put the ones which are same in your classes. I'll try to explain this with the help of one of the design pattern. But before I actually jump onto the design pattern, let me try to explain some of the other things as well, which are important from this design pattern perspective. So, solid principles will cover. I'm trying to explain you the design patterns, and then you mentioned about the solid principle. I know that solid principles are important. We'll cover that in a different way. I'm trying to explain you some of the design patterns, and then you will be able to relate the solid principles. It's easier to actually relate once you actually know about the design patterns, and then you can relate those with the solid principles. So we'll definitely cover all those solid principles as well, but not in today's session. We'll try to understand this, and then we'll eventually cover those solid principles. Okay, Manoj? So you'll be able to relate it in a better way, and that's why I'm taking that approach. Let me open the Miro board. I hope you can see my whiteboard as well.
Not visible to me.
Yeah, not yet for me as well.
But I mean, my document was visible to you, right?
Yeah.
Can you see it now?
Yes.
Is it visible now? Yes,
Yeah,
no?
we can see it. We can see it.
Okay. So let's take a duck class, okay? Let's take a duck class. And what we are trying to do is with the help of, in this, let's say we have a duck class. Okay. In duck class, we have some behaviors of the duck. Duck can actually make noise, they can quack, and they can swim. Okay. And then they can have, we are having an abstract display. So based on the type of the duck, basically the display might change. So now let's say if you have a mallard duck, which is extending the duck class, correct? In this case, my display might change, right? So we'll have, because it's an abstract method, we'll have to implement it separately, because, so this is my abstract class because we have an abstract method here, correct? This, I want to make it as a concrete class, so I'll have to implement this method here. So yeah, just give me a second. So we'll have to implement this display method. So we are actually, displaying something here. Okay. Let's say we have a third class called redhead duck. So what we'll do in this class as well, we'll extend duck class, and we'll have display method implemented here as well. Okay. Now let's say tomorrow we decided to add another duck, which is my rubber duck. Now see, in case of rubber duck, if you'll extend this duck class, the display has to be implemented for sure, but your voice might also change, right? The way that the ducks make noise might change for a rubber duck, because this is not a actual duck. This is some, this is not this is non-living duck, correct? So the quack might change here. So we'll have a quack, and basically for this we'll have squeeze as my method. The noise which will be, it'll be a squeeze or squeak, not squeeze. Okay. Now we want our ducks to fly as well, correct? So what will happen? We'll have to go and change this method to add a fly, correct? Once we add this, then we'll have to, here in this case, this both will fly, but this duck, rubberhead duck, won't even fly, right? This won't fly. So we'll have to implement this and say do nothing, correct? Now let's say if there is another duck which comes into picture, which is your wooden duck. Now for wooden duck, there will be no fly behavior, and there will be no voice behavior as well, right? Correct. So see, if you'll see, there are things which are changing, right? So this behavior is changing a lot based on the type of duck you have taken. So what we are identifying, what is the learning we are getting here is that we are trying to identify the aspects that vary and somehow separate them out. How do we separate them out is very important. Okay, let's try to understand how will we separate them. So what we can do is, instead of writing all the methods here itself, what we can do is we can create an abstract class duck. And let's say we have a fly behavior. This is my interface. And then I have a quack behavior. And then we have public duck, which is my constructor, empty constructor. We have a display method because this is very standard. Then what we have is, we have to basically, what we are doing is, because fly behavior might change for duck to duck, and we might want to change the behavior in future, right? For example, let's say wooden duck, right now the ducks which we have doesn't fly, but eventually we want those wooden duck, we'll put some remote control fan on the top of it, with the help of which the wooden duck might fly as well. So we might want to change their behavior on the runtime. Right now their behavior is that they don't fly, but we might want to change their behavior on runtime. Correct. See, their display might not change, but in case if you want to change their display as well on the runtime, then you should make this as interface, and this should be your the interface should be your composition in this class. We'll see how this will change. Let me finish this. So we have a display, and then what I'm writing is public void. I'm saying perform fly. This is my method, and what this will do is, it will say fly behavior dot fly. Similarly, we'll have public void perform quack. I'll take all the questions. I'm pretty sure that you might have questions. I'll take all the questions once I'll start with this particular design pattern. So we'll say that quack behavior dot perform quack. Or quack behavior dot quack also I can write, not perform quack. I can write simply perform, because you might get confused if I do. Okay. Now see, let's say we have swim and then we have setters for this. So this was perform, and then we'll have to set the fly behavior, right? So we'll have set fly behavior because we might want to change this on runtime. So we'll have to have setters. Set fly behavior will pass a fly behavior. And we'll have set quack behavior. And we'll pass what? Quack behavior here. Okay. And this will be closed here. So we are done with this. Now let's try to understand how will we write my fly behavior interface. So I hope this much is clear to everyone. Now let's write public interface fly behavior. Because it's an interface, it will have just one abstract method, which is public void fly. Now there are different ways in which a duck can fly, right? So first one is, let's say we are having a class, public class, fly with wings, implements fly behavior. Correct. And what we'll write here is, this will be public. We'll implement this public void fly that, and we'll put like flying with wings, something like that. So we'll have a public void fly. And this here I am flying or fly with wings, something like that we are printing. Okay, similarly we'll have fly no ways, implements fly behavior, and here I can say public void fly, I won't fly. Okay. Now let's say we have a mallard duck again. So this was the class which I've created here, right? So now we have a mallard duck again. So we'll have mallard duck class, public class mallard duck. I'm assuming you understood that part. We have extends duck here. And what we are saying is that we will have a mallard duck. So we'll have a constructor, and in the constructor, what we'll do is we'll have a constructor. Yeah, we'll have a constructor for this public mallard duck. And in this one, what I'm writing is that you set your fly behavior to what? You got a new fly with wings. And quack behavior to new quack. Again, I mean, we'll have a similar implementation like fly behavior. We'll have a quack behavior implementation as well. There will be an interface, public interface quack behavior, public void quack, and public class quack implements quack behavior. And in this quack will actually make a noise of quack, something like that. And then we'll have a squeak behavior. Sorry, squeak, public class squeak implements implement your quack behavior, and in that we'll have squeak as my, I'll write public void quack and squeak as my behavior. I'm assuming that at least that is clear to everyone. And let's say third one can be no voice, right? Because uh, the wooden duck might not make any noise. So quack behavior will be equal to what? New quack in this case. Now let's say we are writing for the wooden duck as well. So we'll have public class wooden duck extends this duck, and in the public wooden duck, what we are saying is you have fly behavior is no fly, new no fly, and quack behavior is new no voice. This is the third part of third class which will implement. So we'll have for quack behavior we'll have no voice, we'll have squeak, and we'll have quack. So these are the different implementations for the quack behaviors interface. Correct. Now what will happen? So this is done, and we'll print this. We are done. We have set this. So we have set this to this and this to this. So we are set here, right? Now let's say tomorrow we want to extend the functionality of this particular wooden duck. We want to give them, so that we want to change their behavior to fly with remote control, fly with remote, correct? So what we need to do is we don't need to change anything in this class at all. See, we won't change anything in this class. What we'll do is in this wooden duck we'll have a setter, set fly behavior, or we'll have a set, we already have a set fly behavior. So we, with the object of this particular class, because it's a method which is present in this class, right? And we have created an object of this class with this, we can always set the fly behavior. So what we'll do is in this set fly behavior, we'll pass the fly behavior as, so we'll create a new fly behavior. So let's create a new fly behavior, public class fly with remote implements fly behavior, and we'll have public void fly, and in this we'll write what? Fly with remote. Now what we want to change is we want to change this behavior to fly with remote, right? So without changing this and without changing, in the object itself, with the help of, without changing any class, outside this class we can write what we can write? Wooden duck dot set fly behavior, and what we'll do, we'll have a new fly with remote behavior, and when new fly with remote, and then when I'll write wooden duck dot perform fly, it will actually fly with remote. So let me actually try to paste this in our design, and you can go through all the whatever I've explained, and then we'll go through it again together to understand if, and I'll try to clarify your questions before I move on to the next design pattern. Let's see this. Let's go back. Can you see the document?
Yes,
Yeah, that document is also visible, right? No. You can see me scrolling, right, on the document?
Yes, Prakash.
Okay. So if you'll see here, based on what we have learned, this was my duck. These were the behaviors we had earlier. We had this class, and this class. Now we want to fly as well. So we added another method, which is fine. But see here, we are doing nothing in the rubber duck, and then we have wooden duck, and let's write the wooden duck as well. So let's say have a wooden duck which extends. So do nothing and do nothing. Correct. These aspects are so till now this is fine. This okay, this is my wooden duck. Now I want to change this behavior eventually for this duck from fly to fly with remote. So what we'll have to do in this, we'll have to go and modify this particular method itself, right? So identify the aspects in your application which that vary. So these behaviors might vary with time, right? And separate them from what stays the same. So you know that display of the duck won't change. Okay. And if you feel that the display might also change in future, then you will add a display behavior as well. Correct. Just give me a second. I'm sorry. Can you hear me?
Yeah.
Yeah, we can.
So now see what I'm doing is I am actually because my see here if I want to change the fly behavior I'll have to go and modify this particular object, right? Oh, sorry, this particular class. I'll explain you. I'll try to relate it with your some of the versions as well, the real-time applications, but try to understand this. So you have to go and modify this class itself. Correct. So we don't want to do that because eventually we might want our wooden duck to fly as well. But to do that, we'll have to go and modify this class. Okay. So what I'm saying is I can see that these behaviors might vary in future. So what I'm doing is I'm actually creating an abstract class of duck. I'm adding a fly behavior, a quack behavior, and I'm actually doing perform fly where I have a fly behavior dot fly, quack behavior dot quack. Swim is same, nothing because I'm assuming that this won't change. If you feel that all of these will change, you can create a behaviors for all each of these. And I'm adding a setters as well, set fly behavior and set quack behavior. I don't know why I commented this. So we have set setters for these behaviors as well, so that in future, if you want to change the behavior, then we should be able to do it. Now see, I'm adding an interface fly behavior, and I have fly with wings as one class, which is implementing this behavior, fly no way, and eventually, like after some time, I might want to add fly with remote as well. So what I'm saying is this is my Mallard duck. So I'm quack behavior is new quack, fly behavior is new fly with wings. Public void display, I am Mallard duck. And then in the wooden duck, we'll have this quack behavior with no noise, fly no way, and displays this. I am sorry. And then quack and can't fly. We have this. Now we want, so basically this is their method, right? Because this is the behavior which they have. Now what is happening here? Oh, wait, I can say perform quack. This is my behavior. Why I'm not right? I don't look at this. Yeah. Now this is done. Now I'm saying mini duck dot simulator. I'm saying that Mallard dot perform quack. So if you perform quack, then what will happen? This perform quack will go here because you have set the behavior to voice quack. If you see this Mallard duck class, we have set the behavior to quack behavior dot new quack. It will actually perform quack, and what it will do, because we have this is my quack behavior. So this was my quack behavior, and quack behavior dot quack. So it will call that the dot quack method of the perform quack. Sorry, a quack behavior. Similarly, here I am saying that pub here new fly no way. Sorry, wait. Uh, dot perform fly. So perform fly will call this perform fly method, and it will say fly behavior dot fly. What is fly behavior for the Mallard duck? Fly behavior was fly with wings. So it will call the fly with wings one. So what happens in case of fly with wings? It will print I am flying. Correct. Now same thing we'll do with the wooden duck. So new wooden duck we have created. Now, in case of wooden duck, we have this no voice and no fly behavior. So if we'll do perform quack, we'll see no voice. And for fly no way, we'll print I can't fly. Then we change the behavior to new fly with remote here. So now if we actually go and say wooden duck dot perform fly, then it will say fly with remote. So see, the benefit which you're getting is these are the this is the object, right? And you're able to change the functionality of the object on the runtime. So even if you have, let's say, even if you're able to modify this method, the problem is that you're actually modifying the class, the current class. And if your new client, now let's try to relate it with the clients. So let's say if you have rolled out some feature on the client and then there is an older version of it, and now you have rolled out a new feature where you have a new version where you have changed some functionality. You know that that functionality which might change with the new version. If you don't keep the interface as a part of your composition in your class, then if you're actually changing the, if you want to change the behavior in the new version, then you can't change. I mean, your client might, so let's say that change is on the backend. So you don't want your client to actually upgrade their app, and without upgrading their app, they should be able to get the new functionalities which are implemented on your backend. Are you getting my point? What I'm trying to say? How I'm relating this with the two rollouts, new rollouts. Let me try to repeat this. Try to understand this. Let's say you have a client. Let's go back to the whiteboard. Let's try to understand this. So let's say this was my client. Okay. This was my application. I'm assuming you all are able to see my whiteboard. And let's say there was some functionality here. And let's say on the backend, we had two versions. Earlier, we planned to launch with version 1. Okay. So client is basically, because this is abstracted out here as a composition, what we are saying is whatever is the behavior here, you call this behavior and decide on runtime what you want to display. Okay. And now let's say with new rollout, we want to change this behavior, right? You want to change this behavior. So what I'm saying is you go and set the new behavior for this one, and this will call the version 2. Because you have abstracted this out here, and so on the runtime we can change the behavior of whatever we need here, and that's why this pattern is useful. And this type of pattern is known as strategy pattern. What we say, what does strategy pattern says? So you always abstract out the things which might vary in future. Okay. And you actually keep the keep things which are same in the class. So we have written this principle one here, right? Identify the aspects of your application that may vary and separate them from what stays the same. So let me define the strategy pattern at the bottom of this. So it says that define the family of algorithm, encapsulates each one and makes them interchangeable. So families of algorithm, why? Because there are, in this class you have bunch of fly behavior, quack behavior. Then encapsulate each one. So we have each, these are like different algorithms for me. So this is a different behavior, this is a different behavior. So it encapsulates these behaviors and makes them interchangeable. So you can change these behaviors in future. Right? Allows you to see algorithm as per the requirements of the client. So based on the client requirement, you should be able to vary these algorithms. So tomorrow, let's say if you want to, I'll give you another example, right? So let's say you're creating, okay, let me give you a very standard example, right? So let's say you have some calculator client, and your calculator, you want that calculator client to either have a scientific calculator or switch to mathematical calculator or switch to our normal calculator. Correct. Now, you might want to change the behavior on runtime. So first you might want to use a mathematical calculator. Then you might want to use a scientific calculator, and then you might want to use the normal calculator. So basically, you can create a calculator behavior and you can change the behavior in the runtime as per your requirements. So that is your strategy pattern. So what did it encapsulate? It encapsulated the calculator behavior. This is one algorithm. I mean, there can be other things as well, and make them interchangeable. So on the runtime, you can change the behaviors, right, as per your requirements. So that's why this is known as your strategy. I'll stop here. I want all of you to go through it for a couple of minutes. And if you have any question, then please ask questions. Otherwise, we'll move on to the new design pattern. One more thing which you need to keep in mind is, okay, or what you can do is you can try to write a wooden duck. So I haven't written the, sorry, not the wooden duck. I haven't written the quack behavior. So if you want to try, you can try to write a quack behavior as well with three things: no voice, squeak, and quack. And you can send it over to me on the chat. Let's quickly do this, and then we'll move on to the next design pattern. And in the meantime, if you have any questions, then feel free to ask questions.
Prakhar, I have a question.
Go ahead.
Yeah. So earlier, what the way we have decided to implement is we are having perform quack and perform uh, fly method as part of the same class. Then we have separated it out into an interface, right?
Yes.
So what would happen to the client if rather than having it as a different interface, we would have defined the earlier way?
You'll have to go and change the. So the problem with that is that, let's say if you want to change the fly behavior of the wooden duck.
Mm-hmm.
Can you see my screen here?
Yeah.
If you want to change the fly, so this would have been your fly behavior. Do nothing. Now, if you want to go and change this behavior to I am flying,
Mm-hmm.
then you have to change this piece of code.
Mm-hmm.
You have to ask your client to upgrade their application, or they'll have to use a new class, right? They can't change the same object of the older class because the fly behavior has changed.
Yeah.
Are you getting my point? If you want to relate it with your client, they'll have to upgrade their client, right? Update their client to get the same behavior, which is not the case here. Because I'm saying that I can change the behavior on the runtime. I can set the new behavior in the runtime itself.
Okay.
See, you can't perform. See, you can say perform quack, perform fly, and let's say now you want to change the behavior to new fly remote. You will be able to do it with this implementation, right?
Yeah.
How will you do it with the previous implementation? There is no way. Let's say if you want that let's say that remote is broken now. So again, they can't fly. So you want to change their behavior again to not fly. Can you do that on the runtime with the previous implementation? You can never do that, right?
Yeah. Got it.
Did you understand how this is helping you to change the behavior on the runtime?
Yeah. Got it.
You can try to relate it with this perform fly and this perform fly, right? By setting a new behavior, you are able to change their behavior without modifying anything in the classes which you have written.
I got it.
Understood?
Yeah.
Okay. Anyone else who has any questions? I quickly go through it because I know that you might have more questions, and try to understand this, like why we have designed it like this, if you have designed it like this.
And Professor, one more thing. Are you there, Prakash?
Yeah. Go ahead, ask a question.
Yeah. So I believe if we are going to implement it without the interface behavior, it will also violate the Liskov substitution principle, because
That's correct.
in that
That's
case the
it's
wooden duck would not be substitutable by the.
exactly. That's correct. But let's please let's not talk about the solid principles for a day or so. Let me actually try to cover all these. I mean, see this whatever I'm writing, right? Design principle ones. These are related to your solid principle itself. I'll explain you this, but you're correct. I mean, it will violate the Liskov principle if we don't actually extend this, if we don't use the interfaces there. Correct. Okay, that's correct. You're right, very right. But let's avoid those solid principles for some time. We'll cover it in next class or next to next class, basically, because I want you to understand this first, and then you will be able to relate those solid principles in a much better way with the examples which we are taking here.
Okay.
But you're right. Uh, if we don't use the interface, then we'll violate the Liskov principle here. That's correct.
Okay.
Anyone else who has any questions here? Sorry, so sorry. I'll give you a very simple question, right? Maybe you want to give it a try on your own, and I want you to create a. Uh, I want you to create a strategy. Create a strategy where you have to actually do the operations. There are I want you to create a class which will take two integers, and on the runtime you might want to add those two integers, subtract those two integers, and multiply those two integers. How will you actually create this? Can you people try to write it very quickly? So I want you to create a strategy. I want you to create a class. That class has two integers. One is your basically one is your number one. The second one is your number two, and you should be able to perform operations on the runtime. I'll give you 2 minutes to think about it. I don't want you to write the complete code. Just write on a top level what all things you'll need, and then we'll try to see how to actually, I will quickly write the solution for the same, and then you can fill it later on. I'll give you the high level view of what exactly has to be implemented in what, and then you'll understand strategy pattern better. So I'm saying that there is a class called, let's say we have a class which is perform operations. Right, perform operation class. In this perform operation class, you want integer num1 and integer num2, and there is something called perform operation method, and I want you to change the behavior, and this will return some integer, and I want you to change the behavior of this perform operation on the runtime. Right? So it will return, I mean, the behavior should change on runtime. Whether it should be able to perform multiply or plus or minus based on the behavior. Or if you don't want to take this integer here, you can take these integers here as well. Either way is fine. I mean, because you might want to, I mean, you have to write the getters and setters here. So like we can skip that. So this perform operation, the behavior should change on runtime. Or we can say execute strategy. If any one of you has any idea as well, you can unmute yourself and speak. Otherwise, I'll give you 2 more minutes. Try to quickly write it because I'll want to cover at least one more design pattern in today's session.
I think when we are initializing the class, that time only maybe based on the user operations, we will call up the interface based on the operation we have.
Okay, let's take this as a homework. I want all of you to figure out this. Let's take this as a homework. What I'm saying is, you need to figure out a way to extend this class. I mean, you can add more data types. I'm fine. Data members, member functions. I'm fine with that. Figure out a way to extend this class to change the behavior, the operations, and let's say if you want to support add, subtract, multiply on runtime. Try to figure out this on your own, and then we'll discuss this tomorrow's session or after. Okay. Cool. Let's move on to the new design pattern. So see, now let's say we want actually, this is again an interesting pattern and we'll try to understand this. So let's say you're actually creating a weather data monitoring station that pulls the humidity, temperature and pressure. That's a weather station which pulls a humidity, temperature and current pressure of the atmosphere. And you'll try to write, so you'll have a weather data and you have multiple display boards, right? You can display in the statistical format, in the forecasting format, in the current condition format. So based on different ways, you can actually display this. So what you have is, let me try to explain this just a second. So how will you actually create this pattern? How will you write this pattern to make sure that on the runtime, your behaviors or your if the temperature is changing, then you should be able to pull that. So what we are trying to do is we are doing this. Let's try to write it down here as a question. There is a weather station which pulls the humidity, temperature, and pressure. There is a weather data object which displays the change in humidity, the temperature, and the pressure to three different display systems. So what we have is we have a public class weather data, correct? And we have public void measurement changed method. And what we have is here we are getting the new temperature, the new, so float temperature equal to get temperature. We're getting a temperature, we are getting the pressure, and we are getting the humidity. We have this, and we have this. Temperature, humidity and pressure. Get humidity and get pressure. Okay, so these are the three methods which we'll have. Basically, this is my measurement changed. And basically, once this is changing, then there are display boards. So we can write that there are current condition display, and there is an update method. So there is a public class called current condition display. Public class current condition display. And what this display is doing is it is just displaying the current condition. So we have, let's say, it has some update method. And in this update method, it takes the temperature, float humidity, and float pressure. And it will just display this. So we have humidity and we have pressure. And it will display this. Okay. This is my update method. Or what you can do is you can create a public class. Actually, you can create something like this as well, right? Public class display condition display this, and here we can have what we'll have an abstract method called, we'll have all these float temp, this and this, or we don't need that. We can say display method is an abstract method. Takes three parameters. This, sorry, not display, update method. And this takes this three, it updates all these three. This is my public void update method. And basically you override this method here, right? Public void update, and what it will do, it will update the temperature, pressure. So we can, I'm not writing that code now. We can update with the current display, and here you'll have, let's say, float temp, float humidity, and float pressure. Sorry. Float, these are my variables in the display book. Sorry. This is my float. These are my data members. Temperature, float, humidity, and float pressure. And this is my public method. Okay. And then we have a current display. Similarly, we'll have, let's say, statistics display. And then we have, let's say, another one called future forecasting display. Forecast display. This much is clear. This setup, this is very simple, right? So whenever this is changing, my weather is changing, I'll call current condition display dot update. So an object of this class, we'll have object of this class here. Correct. We'll have current condition display. That's how we'll write it, right? Condition display. We'll have statistics display, and we'll have forecast display. And then we'll have forecast display. We have these three displays, and we'll have to call each of this. So current condition display, we'll call this update. Dot update will pass all the three parameters: temperature, humidity, and pressure. This seems like a fairly simple thing so far. Now we'll have similarly we'll have statistics update display, and we'll have forecast display. Correct. Now let's say, again going back to the same principle, that your class should be open for extension and close for modifications. This is one of the principles which we'll see soon as a part of the solid principles. But basically, going back to the same principle that you should, the first principle which you have learned here, right? Identify the aspects of your application that may vary and separate them out, which stays the same. Now here, it's a bit different here. But now say tomorrow, let's say if you want to add another display system, correct? So tomorrow, if you want to add another, so okay, this will extend current display. I forgot to mention this. This is not a method. So tomorrow you decided to add another display system. Now you'll have to go and modify your weather data class, right? Because you'll have to add another display and then you'll have to modify the measurement change. So did you understand, all of you understand the problem with the current implementation which we have? Okay. So we had 3, we actually did this. Or tomorrow, let's say if the forecast display is not working and we don't want the forecast display anymore. So what we'll have to do, we'll have to go and remove this. We'll have to go and change this class and we'll have to remove this from this class. Correct? So that's an issue. Correct? So can I say that there is no way for you to add or remove, no way for you to add another display system or remove the current display system without modifying the code? Right? So this is clear to you, right? This is the learning which you have got. So basically, can we say that what is the learning? So learning is that basically the learning is that there should be a way to register these displays in a way in this weather data so that we should be able to change the behavior on the runtime. We should be able to add or remove the displays on the runtime. Now see how I'll do it. So I'll create, so now we'll try to learn the observer pattern. Okay. Learn observer pattern. Now see how this observer pattern will help you to do this. So what we are saying is we'll create a subject class. This is a very standard way to actually write any observer pattern. Okay. So we'll have public interface subject. This won't change for any observer pattern. And there are 3 methods here. One is basically register observer, remove observer, and notify observer. So we'll have public. This won't change. Okay, this will remain same across all the observer patterns. So we'll have register observer. We'll take observer is a class, observer O. We'll have public register, remove observer, and notify observer. Okay. This is my subject class. This is known as a subject class. We'll have remove observer, and then we'll have notify observers. This is my interface. Notify observer won't take any observer. Notify observers. Okay. Now this is my subject class. Now we'll have to write an observer class. So see, what is the observer interface here? This is more like an observer interface, right? Update method. So what we'll do is we'll write a public interface observer, and in this observer, what is changing by this update, right? So we'll have public update. What is this? Void update this. This is clear. I mean, it's an interface, so it can't have a data member, right? So we are having an interface observer, and we have an update method, and this is my subject. Now this is my weather method, data method class. So we'll copy this again and see the way I'm writing this. I'm saying that this will implement subject. This will implement subject, and what we'll have in this subject is we already had this, right? So we'll remove this all, and we'll say that now we'll have an array list of observers. Okay, this is my observers. Because this is my subject method, and we in this subject method we have register observer, remove observer, and notify observer. Correct. So these are, because it is implementing, so we'll have to basically implement the three methods as well. So I'll remove this as well. And I'm saying that you take these as a global variables. Now you say that this is my float, not global variables, basically data members, temperature, float, humidity, and then float, pressure. And this is my array list of observers. And measurement change, you will say temperature, you will get a new temperature, you will get a humidity, and you'll get a pressure. Now see what I'm writing out, how this observer will be called from here. We have written this. Now what we'll do is, whenever we are having a weather data class, we'll have public weather data, and this is my constructor, right? So we'll write here observers dot equal to new array list. I'm assuming this much is clear to everyone. So I'm initializing this array list, and now what I'm instantiating the object of the array list, and then what I'm saying is, okay, let's wait for measurement change. Let's write the subject method first. So what we have register observer. So what we'll do is, whenever the register observer is called, we'll see how this will be called. So what we'll write whenever this is called, what do? You'll say array list observers dot add o. I'm assuming this much is clear to everyone. Then there is second one, remove observer. So we'll say correct. So we'll have to see. First you'll have to find, I mean, it's very easy to write it. Int I is equal to observers dot index. This is a Java method, okay, to find the index of this object, and if it is present, then if I is greater than equal to 0, I'm writing. Otherwise it will return -1. If this is the case, that means that it is already present. So what I'll do, I'll say observers dot remove I. Assuming this much is clear to you. Now we have something called notify observers, right? So what we'll do for notify observer, we'll have public void notify observers. We have to notify all the observers for the updates. We'll remove this. And what we'll write is, here we'll have a for loop for int I is equal to 0, I is less than observers dot size I plus plus. And what we'll write here, we'll say that observer, should I just copy paste this? I've already written this. No, it's not this time. This is fairly simple, right? So we are saying that observer is equal to observer dot get I. We are getting the index, and then we are updating with the temperature, humidity, and pressure, because this is my update method in this interface, you can see. And if nothing is happening, then we are rescheduling the message, or I mean, if it's a reschedule message or whatever you want to do, you can handle the exception and you can say something or whatever you want to do here, right? You need to handle the exception. Okay. Now in the measurement change, what will happen? We'll have to write the notify observer method after this, right? So the measurement change is happening. So measurement change is, we are getting the new temperature, we are getting the new humidity, we are getting the new pressure. And after that, what we'll do is we'll say notify. Whenever there is a change in the temperature, humidity, and pressure, we'll notify all the observers. Now, what were my current display? So we'll have, now we'll copy this, all the three methods which you have written above. Public class condition display, this, and forecast display. And see now what I'm writing. This is done, and here I am, right? So now in the current display, this will have current, this is my condition display, which is still extending the condition display, correct? And condition display ideally should have just the display method. It should not have an update method. So let's say we'll have a display method here. It's a display, right? I don't know why did I write that update method. Or you can have an abstract update if you want. In that one, you can have an update. Here, you don't need an update. So display will just display everything for you, right? We'll say we'll have a condition display. This is sys. We'll do sys out here. Correct. Sys out. In some or the other way, right? We're just printing this. Now, sorry, the condition display is extending this and implementing what? Observer. Implements observer. And when we actually create an object of this class, so can we say that whenever we are creating this, so when we are creating this, can we say that, let's say this is my public current condition display, this is my constructor, and we'll take the subject here to with which we want to register. So we'll say weather data, register with this. And what we'll do is here, we'll say that this dot, and we'll have a weather data as well here, right? We'll have a subject here, we'll use the subject here. So in the current display, what we'll have? We have, yeah, this is my current display. Let me recognize this. And here we'll have what? We don't need a condition display. This is my void. Let's remove it for something. What I'm saying is, here you'll have to have a subject, private subject, weather data. And what I'm saying is this dot weather data equal to weather data. And what you can do is you can say weather data dot register observers. We'll pass observer as this. So this is the current one, right? So we'll actually register this as an observer. And then finally, what will happen if whatever you want to update, you can update. Whatever you want to display, you can display. So here display is already fixed. We'll have to just write the update method because its update is display method implements observer.
Yeah, I think we have to update because the interface has an update method.
Interface is an update, right? So you have to write the update method. Not here, sorry. Here we'll have to write.
Yeah.
Correct. And this what this will do is we'll have an update here. It will take all the float, whatever we were taking in the observer. Where is my observer?
Float
This.
temperature.
Correct. And whenever we have this, then basically we'll update the temperature, pressure, and whatever. Right? So temp equal to temp, or this dot temp equal to temp. You can write this on your own, and so on. And then finally, we can call the display method after this, whenever anything is changed. And similarly, you can implement it for the statistic display. So I'll write a to do here, and I'll write a to do here as well. And now we'll have a main class, weather station, which will take care of. Now see how this is. So we have a public class, weather station, and in this, what is happening? We have not writing the whole code. I'm saying that this is my main class. You can write public static void min string args. I'm not writing all those stuff. Okay. And what I'm doing is first I'm creating an object of the weather data class. Here is my weather data. So I'll create an object of this weather data equal to new weather data. Then I'll create a current display. I'll say current condition display dot. So we'll have a current condition display here, and we'll pass the new weather data as a part of this constructor. We'll have it's a new current display, and we'll pass the weather data. Similarly, you can create a forecast display and statistical display. I'm not writing that. And you do the weather data dot set. What is it? Change measurement or set measurement? What was that? Measurement changed. So this will just get the new temperature, pressure, and whatever that is. And then automatically, when this will be changed, this will be changed. Where is this? Yeah, whenever the measurement change will happen, this will be updated and we'll try to notify all the observers. Notify observer method will actually, so all the thing will register as an observer, right? Whenever this constructor is called, and it will notify the observers. Where is my notify? It will go to each of the observer. It will call observer.update. So observer is right now my observer. The first observer is this one. Current condition display. It will come here. It will actually update this, and it will actually display the. And similarly for the forecast display, and similarly for that. So basically, if you want to add another one tomorrow, let's say after you're done this, let's say there is new display, new condition, new display board, a new display system. So what you can do is you can call this new display system equal to this, and you'll call this as a new display system, and you can register this as a. Sorry. This will be registered as a new display system in our new. It's a new display system, and will pass weather data. And this will be automatically registered as observer. Why it will be registered as an observer? Because in the constructor of this, we are writing weather data dot register observer. And if you want to remove a particular observer, then you simply do what? You have the weather data, so you say weather data, but remove observer from here, and it will be removed as an observer from here. If you want to remove this current condition, this.
But Prakhar, this is not happening on the runtime, right? So we are always calling.
This is main, right? This is runtime.
Okay, so we are saying that whenever
we can always change, right? We are not touching anything else here. See, this is the method which you can always change, right? You're not changing the classes. Did you understand what I'm trying to say?
I get it. I get it. I was just trying to be more on the runtime that whenever the observer is not in a good state, it will be automatically removed. But right now, when we are writing that code, that means we have to change the. Yeah.
No, you're not. You don't have to change the code. Where are you changing it? I mean, you have to change the main class. You'll have to. So someone has to say that observer is not in the good state, right?
Yeah.
How would you identify? But that's on the runtime only, right? So on the runtime, you can say that remove this observer.
I was thinking that is something to an automated process that okay, we don't.
It's an automated process only, right? See, main is just a class. This will be converted to API eventually.
Correct.
I keep telling you this, right? This is more like an API only, right? I explained to you in the last session, right, how to convert the main into APIs. The chessboard game, if you remember, right?
Yeah.
Here we did design, right? First we did LLD and then we moved to HLD. And the main was converted to the APIs which we had. Correct. Similarly, we'll have an API here. Correct. So the API will be that remove this observer. So that we'll have an object of this class. Once you have the object of this class, you can remove the observer. Are you getting my point?
Yeah, got it. Okay.
This is on the runtime only, right? Whatever you're writing, this is on runtime itself. You're not touching any of these classes if you want to take any actions. Did you understand?
Yep, I get it.
Any one of you who has any questions?
Prakhar, I have a question. In
Yeah.
this observer interface, I understood that we have an interface and we have a different implementation. But for weather data, is there any need to have a subject as an interface and then weather data will be implementing the subject?
Yeah, because you'll have to have this register of, these are my method, observer methods, right? So basically always you have a subject and the observer. This works hand in hand. So this is my weather data, which is my subject.
Is there any possibility that the other day we have a different subject?
Yeah, you can have, so you implement another subject. That's why we have the subject, right? This is my interface. That's why you can have a different subject altogether. And you can register that when you're actually doing this, you might pass some other weather data station, right? So this object might vary, right? The weather data might vary. Like you might want to have, so let's say there are 3 weather data. One is in Indore, one is in Bangalore, one is in Mumbai. 3 weather data systems. All 3 are different. Now this condition display might be for your Bangalore. One condition display might be for Hyderabad, one for Indore, one for Mumbai. So you can vary the weather data, right? You might not want to show the, I mean, you don't want the condition display in Mumbai and Hyderabad. You just need in Bangalore, correct? So you'll create a separate one display board for Bangalore, and you pass that particular weather data here.
So in that case, there would be a different subject for that.
I mean, it's not
Different
a different subject. It's basically a different
class
it's like a
implementation.
publisher and subscriber, right? There can be multiple publishers, there can be multiple subscribers, correct?
And if
So
we know
one,
that the subject is not going to, I mean, there would not be the multiple classes of subject, then we can have it as a class itself, right?
I mean, you can remove this subject altogether and you can put all these as register observers and everything here.
Yeah.
But why to actually run into that? I mean, you will never do that, right? Because as I keep telling you, right, you want to design this in a way that there can be multiple publishers and then can be multiple subscribers.
Okay.
That is the whole logic of publisher and subscriber, right? So multiple publisher can publish the message, multiple subscriber can subscribe to a message. Observer pattern is based on the publisher subscriber model, right?
Okay, got it.
I mean, if you know that there is only one publisher, you don't need a subject interface there separately. Correct?
Yeah.
You have only one observer, then you don't need an observer interface. You can just have one observer, one publisher. You can do similar things what I'm doing. See, abstraction always helps you to extend, as I keep telling you, right?
Yeah.
It should be, your classes should be
Extensible.
extensible, correct? And they should be closed for the modifications. By having the subject as an interface, you can relate that if any class is implementing the subject, then they have to make sure that they implement these 3 methods for sure. So you are actually giving that responsibility to any class which is using this particular interface.
Got it.
Understood? Okay, so this is my observer pattern. We'll stop it here. We have covered 2 design patterns. I want you to revise it thoroughly and try to think. Let me see if I can give you a homework on the observer patterns. Let's try to find if I can. It's not very difficult. So sorry. I'll try to find an example of observer pattern, or you can try to find an example of observer pattern and just try to observer pattern example. Just try to write that on your own. That will help you to understand this. So let's say you have you are actually designing a cricket display board, and you have an average score display board, and you have current score display board. So you have to write the So you have to design a cricket scoreboard, and this board should be able to display the current score, and there are two boards and average score. Okay, you have to design this. Try to think of how will you actually do this. So there will be something called there will be some class called cricket data, and then there will be average scoreboard and current scoreboard. How will you handle this with the observer pattern? Try to think of the solution, and then we can discuss that as well in the next session. And let's see if I can cover any simple one. I'm not sure how many of you are already aware of singleton pattern, but I'll try to cover singleton pattern and maybe factory patterns in the next session. And in the next session, we'll cover the decorator pattern. That is the only important one which will be pending after that. And after that, if you have any questions in the next sessions, I can take those questions, and we'll try to cover the LISCO solid principles, not the LISCO ones, in that session. And and then we'll have ad hoc sessions as I told you. So today we have an ad hoc session. I'll try to share the details on that group in some time. So if you are interested, you can join that session today.
And Prakar, so just wanted to ask, I think I missed the last two classes. So how many sessions more are left, if I can get that?
So basically, we'll have two sessions, which will be with this batch itself. And then there will be 5 to 6 ad hoc more sessions in which will be added, where we'll be just practicing more and more questions, because we have already covered all the concepts. So we'll try to solve some difficult question as a part of those sessions. Okay. And once in a while, we'll post more ad hoc classes as well. So if you're interested, you can always join.
Absolutely. Yeah, what for me, I can tell about this low-level design, something which is something giving some hiccups. So I think that's where I need to focus. But yes, any tips on that side too, Prakar, to work on the LLD side?
I mean, see, the only way, I mean, I already told you, right? We have discussed a bunch of low-level design questions in past. The strategy is same. You figure out all the requirements, you figure out what are the actors, you figure out all the use cases, you figure out the entities and classes, and then you try to draw an entity relationship diagram. There is no easy way to actually build expertise around these unless you actually practice more and more questions. Once you start practicing, it becomes easier for you to actually think about all the classes and how these classes are related with each other.
Sure.
Okay.
And Prakhar, one more thing. Yesterday we discussed elevator design. So from the design wise, it was clear. But is there any chance interviewer will go to the detail of scheduling, and I mean how the elevator is going to pick up a request and low level data structures, what are going to be used, and all these things?
See, that's very rarely you asked, because to be honest, you can't cover that in 45 minutes, and most of the interviews will run only for 45 minutes. So that is generally not the expectation. In that case, the question might be a different question.
Because it is going to be very complex then.
It will be complex, and no one is expecting you to figure out the solution within 45 minutes. And in that case, you can give a very simple solution, right? The one which you are discussing with the help of two parameters. Let's say one parameter can be when we are going up and what is the current request. When we are going down, what is the current request? Give a simple solution. Start with a simple algorithm in those cases. They won't expect you to come up with a very complex algorithm within 45 minutes along with the design. That's not the expectation. They want to see how you're designing the classes. So you should understand. You need to understand where to transfer the responsibilities to some other classes. For example, I don't know if you have discussed the Uber design. In the Uber design, I told you, right? Like third-party system will figure out what is the nearby cells for you. Now there is a logic to do that as well, right? Now you can't build that complete logic in the interview. That's not practically possible. So generally, that is not the expectation. The expectation is that you are giving a decent solution by abstracting out some of the things, and I mean the solution which can be extended by the design should be extensible, and that is good enough for your interview. Now you can't add everything, because let's say if I'm asking you to design a Twitter, I can't expect you to design the complete Twitter within 45 minutes. Right?
Mhm.
Same goes with the elevator design as well. Okay.
Okay. Thanks.
Cool. Thank you so much. We'll meet on next Saturday and we'll try to complete the remaining design patterns, and then after that we'll start with the solid principles. And as I told you, I'll share the details of today's session in the group itself. Bye. Thank you so much. Have a nice day. Take care.